Good afternoon everyone, and welcome to my next worked exam answer video. Today I'm having another look at an organic chemistry question, this time focusing on the aromatic chemistry topic, which appears in the year 13 component of the AQA course. And I've chosen this one because I'm going to approach this perhaps in a little bit of an odd way, in the sense that we are asked to give an overall reaction for benzene reacting with methanol chloride, and we have to name the organic product in part A. And what I'm going to do is I'm actually going to do the mechanism for this reaction first, so do part B and then part C, and then come back and do part A. And the reason why I'm going to do this is because I think it's potentially tricky to write an overall equation for a reaction until you've visualized what's happening in terms of the mechanism itself. And I want to show you guys that actually there's nothing to stop you from doing the parts of the questions out of order, particularly if you find it easier to do a mechanism, work out what the final product's going to look like, and then use that to help you to convert it to a structural formula to be able to put it into an equation. So that's why I decided to choose this question. And I also specifically chose this one because we aren't reacting the benzene with the usual ethanol chloride. We're using methanol chloride, which isn't that different, but it's going to make a big difference when it comes to naming our organic product. So that's another reason why I picked it. So we will read from the top, but like I say, I will skip part A and come back to that at the end. So we've got benzene reacting with methanol chloride in the presence of a catalyst, and we have to give an equation for the overall reaction when benzene reacts with said methanol chloride, and then we've got to name the organic product. We'll come back to that. We do need to know what this catalyst is, and it's asking us to identify it. So identify means that we can either name or give the formula of the catalyst. Name, obviously give name, formula, then give the formula. Identify, you can do either. I think it's easier to do formulae, but that's my choice. And then give an equation to show how the catalyst is used to form the electrophile, and they've been very kind in giving us what the electrophile is. Now, when we have benzene reacting, it's always going to be via electrophilic substitution, because the benzene ring, the ring of delocalized electrons, is a region of high electron density, and that's going to want to attack something that is going to be able to accept a pair of electrons from the benzene ring, which by definition is an electrophile. So we need to figure out how we're going to change the HCOCl into HCO+. And what we're going to do is get rid of the chlorine. So we're going to break the bond between the carbon and the chlorine, with both electrons going to the chlorine, which will leave the carbon with the positive charge. The catalyst that we use to do this is aluminium chloride, AlCl3, and when we're forming the electrophile, we are going to put the catalyst into the equation, which might seem unusual because catalysts, as we know, aren't chemically changed over the course of a reaction. And so we don't normally put them into equations because that looks like they're being reactants, but we will reform the catalyst at the end of the process using the H+ that gets substituted in the mechanism. So we are okay to put the aluminium chloride into this equation. With the methanol chloride, apologies, HCOCl, and if the C to Cl bond is breaking and the electrons are both leaving with chlorine, then we will end up with that as our electrophile, or you can obviously write it as they've done there with the square brackets and the plus, but I want to write it like this to show you that it is the carbon that has the positive charge, and therefore in my mechanism the ring of delocalized electrons will be attracted to the carbon because that's what's positively charged. And if the chlorine is leaving with both of the electrons, then that's going to be leaving as a Cl- ion, which the aluminium chloride will pick up, form a dative covalent bond where the chloride ion gives, or donates rather, a pair of electrons to the aluminium, which is electron deficient, and we end up with AlCl4-. As I said, when we then come to reforming the catalyst, the H+ that gets substituted will react with this intermediate to give us AlCl3 and the second product, which we will write down in our overall equation. So that is an equation that you might be asked to write. It's fairly commonly asked. You might also be asked in terms of the catalyst like we have here, or to be able to identify which specific acyl chloride is needed to generate a particular product. So if they give you a synthetic route, you might need to say, oh yeah, the reagent is going to be this specific acyl chloride. So now we're going to outline the mechanism. So we don't need to name it, and I knew they weren't going to ask us to name it because they gave us a clue here about formation of an electrophile. In other questions where they do ask you the name of the mechanism, they'll probably say, give an equation to show how the catalyst is used to form the intermediate species or the reactive intermediate or something along those lines, because they don't want to give away that it's electrophiles that we're thinking about, because that will give away the name of the mechanism. But we don't have to name it here. We just need to outline it, and we're doing it for benzene reacting with the electrophile. So there's my benzene with my ring of delocalized electrons, and then the carbon will be bonded to H, double bonded to the O, and then we'll have the positive charge there. And for my first curly arrow, we need to have, starting at the ring and pointing to the carbon of the electrophile. And then that gives us an intermediate in which one of benzene's carbons, and it doesn't matter which one because we are just starting with benzene, there's currently nothing on the ring. So one of benzene's carbons will now be bonded to the electrophile and the hydrogen that it was already bonded to. And this is where sometimes students can forget the hexagon with the circle inside is the skeletal formula for benzene, but don't forget that each carbon does have one hydrogen bonded to it, molecular formula of benzene being C6H6. So if that carbon that I've chose to put the electrophile onto is now bonded to the electrophile as it was, the hydrogen and two carbons, it no longer has a delocalized electron. So when we come to draw the ring, we draw it in a horseshoe shape. Now it cannot extend past this carbon or this carbon, i.e. getting closer to the carbon with both things attached. So be really careful with this to not have your horseshoe extending too far, because they will be quite picky with that. Likewise with the positive charge, don't put it too close to this carbon. They want it to be a minimum of sort of on a line between carbons 2 and 6. So yeah, go for the middle. That will work. And then that will get you a mark. We've already got a mark for this curly arrow, and then the final mark comes from the final curly arrow, which is showing how the electrons from the carbon-hydrogen bond go back into reforming the ring of delocalized electrons, because we cannot permanently break that, because otherwise benzene will lose its stability. That's why benzene will not undergo addition reactions, and it has to be substitution. Now, we don't need to draw the product to get any marks in our mechanism, but as I said before, it might be helpful for us writing the overall equation. So I am just going to draw the final product. You can draw the final products of mechanisms, and you should if multiple products can be formed, but where there's only one product that can be formed, it's not necessary, and if you make a mistake you will be penalised, unfortunately. But that is the structure that we have. Now normally when we do this question we use ethanoyl chloride, so we would then have a CH3 where this hydrogen is. And if we have a CH3 where that hydrogen is, that actually then makes this a ketone. but it's not a ketone because we only have a hydrogen here, so this is now an aldehyde. And I don't suppose that many of you have had a go at naming an aldehyde with a benzene ring on it. The way in which we do that is we would call it benzaldehyde. However, I don't think that's particularly obvious as to where that comes from, and the naming of benzene-based compounds is a bit of a pet peeve of mine because sometimes it's based on benzene and sometimes it's based on phenyl. They will let you have phenyl methanol, and I think that's probably a bit more logical and easier to work out, and also more similar to the ketone, which we previously said if there was a CH3 here would be phenyl ethanone. I think it makes more sense if we then go, oh, phenyl methanol, because it's an aldehyde. But we can call it benzaldehyde, so I'll put both names down up top. And now we've also got this, I can also have a think about my overall equation. So benzene will need to be C6H6. And then we've got the methanol chloride, HCOCl. Now, the organic product, which is our benzaldehyde, that's now going to be C6H5, then because it's an aldehyde, CHO. Remember, yeah, we always put the hydrogen before the O in an aldehyde so that we don't confuse it with an alcohol. And then the other product that we get comes from the Cl that we booted off the acyl chloride in the formation of the electrophile, and the H that we've got rid of in this part of our mechanism. So this H will leave as a H+, that Cl left as a Cl-. They come together to give us HCl as our second product. So that would be our balanced chemical equation. We don't need to include the catalyst in that, which is why they've asked us about the catalyst afterwards. If you did want to put the aluminium chloride somewhere, you could put it on the arrow, but you don't need to. And then, like I say, this, which is our organic product, and I know that that is my organic product and not HCl because that doesn't have any carbons in it. An organic product is one that has a backbone of carbon and hydrogen. So, as I said, we can call this benzaldehyde, or, which I think makes probably a bit more sense in the grand scheme of things, phenyl methanol. And there we have it. So hopefully that shows that you definitely do not need to do the questions in the order that they appear, and always feel free to attempt whichever part feels easiest for you first and use that to your advantage to then help you to go back and maybe write equations or name organic products. Okay, if anybody has any questions, as always, please do not hesitate to let me know, and I will be back with another video soon. In the meantime, any requests, please just leave me a comment, drop me a message or an email, whatever works best for you guys. Hope all is well with you, and I'll catch you again soon. Thank you for watching.